Hello everyone, welcome to the engineering mechanics tutorials. So here we are going to discuss about an example problem on Lamis theorem here. Here the string is given ABCD which is attached to the two fixed points A and A, okay, as shown in figure, and these are given with the two equal weights of 1000 newtons at two different points like B and C. Okay, the weights rest with these portions A, B and C, D inclined at an angle as shown. So that means here after giving the loads, the inclinations are also given with vertical lines. Okay, here we need to find out what are the tensions will be taking place inside the AB string and BC string and as well as CD string. Okay, with reference to the diagram it has given. Okay now, so for finding the required tensions, okay, here the tension, so whenever the load is applied, certain tensile forces will be stored inside the string. So to find out that tensile, that is the tension force inside AB string and BC string and CD string, we need to apply the Lamis theorem condition. Okay now, so for that I want to select the two different parts of the problem. So how can we select the two different parts of this problem? That is according to the figure is given means here. So I want to select the first part as B joint. Okay now, divide the ABCD string into two different parts. So for that I want to select the B joint first. Okay now, with reference to this B joint, what are the strings we can represent means one is AB and another one is BC. At B point what is the load is acting. Okay, these things we can represent in the first part, that is when you consider B point. Okay, so now joint B, so this is the representation and this arrow mark represents the how the tension is acting, the direction of the tension taking place according to the load acting in downward direction. If the load acts downward direction, the tension will be in upward direction like this. Okay, now whether the other joints are given to these AB and CD strings. Okay now, so in this condition already he has given certain angle values here. So with this vertical line, this AB string is making an angle of 30 degrees, and again this BC string is making an angle of 120 degrees with this load line, vertical line. Okay, according to this we need to find out what is the angle between this AB string and the load, and similarly the BC string and the load, and again we need to find out what is the angle in between total BC and AB. Okay, so how to find out means here this string AB is making an angle of 30 degrees with the vertical line. Okay, now this vertical line again is parallel to this load line. Okay, now action of the load, acting line of the load, that is 1000 newtons. So these two, when you observe keenly, these two lines are parallel to each other and this line is intersecting these two parallel lines. So according to the parallel lines theorem, geometry of parallel lines, we can write it as, so this angle also 30. If it is 30, automatically this will be also 30 according to the parallel lines theorem. So represent the 30 degrees here. Okay, similarly, so here when you consider this vertical line, the angle of this vertical line is total 180 degrees. Okay now, so if you want to get the angle between this load acting line and the AB string, you need to subtract this 30 degrees from the 180 degrees angle. So when you subtract 30 degrees from 180 degrees, the angle between load and the AB string will be getting, so 180 minus 30, ultimately it will give you 150 degrees. Okay, and next we need to find out what is the angle between this load and the BC string. Okay, here again when you consider the right side of the vertical line, that is the line of action of the force, so this vertical line will be having 180 degrees. Again 180 minus 120 will give you the angle between load acting line and the BC string. So 180 minus 120 will give you 60 degrees. So ultimately we get the 60 degrees. Okay, so now we have determined the angle between the two forces. Okay, now that means angle between BC, that is the tension force acting, and AB, tension force acting. So sum of these two will give you the total angle. Similarly, angle between AB and line of action of force 1000, and again angle between 1000 line of action of the load and the BC we got. Okay, so before that try to represent TAB. TAB is the tension in AB string and TBC is the tension in BC string. Okay now, so with this information we need to apply the Lamis theorem. So now apply the Lamis theorem to this B joint. So how to apply means here T by sine 60 degrees. Okay, TAB here, when you consider the tension in AB, okay, that is by sine of angle between the two opposite to other forces. Okay now, so when you consider the tension, this opposite angle we need to consider in between the two remaining forces, that is tension in BC and the load is acting 1000 newtons downward direction. So for that TAB by sine 60 degrees will be getting. Similarly if you consider TBC, so TBC, so this line is the TBC, TBC by again sine of angle between the remaining other two forces. So that is AB, that is tension in AB, and the load acting downward direction. So the angle we got it as 150 degrees. So we have to write it as sine 150. Similarly, we need to write 1000 load by angle between remaining two tension forces. Okay, now tensions inside the BC string and the AB string. So the angle between these two will be 120 plus 38 will give you ultimately again 150 degrees. Okay, now? So in this condition, we have to find out what is the tension in AB, what is the tension in BC. So for finding tension in AB, so take this ratio, first ratio, this is the last ratio. So in that we can find out the unknown term, that is TAB. So write down separately these two terms, TAB by sine 60 is equal to 1000 by sine 150 degrees. Okay, similarly TAB is equal to, how can we write it as? So before that I want to modify the equation. So sine 150 can be written as sine of 180 minus 30 degrees. So sine 180 minus 30 degrees means same sine 30 degrees we will be getting. Okay, now 180 minus theta will give you sine theta only. So according to that we'll get this modified form. So again TAB is equal to, we can write it as 100 into this sine 60 will comes here. Okay, now so again by sine 30. Okay, so simplify this equation by using the calci, automatically you will be getting the value, that is the tension in AB as 1732 newtons. Next we have to go for finding the tension in BC. So for that, tension in BC, oh sorry ma, just go back to this again. So how to find out tension in BC? Tension in BC can be directly determined here if you consider these two terms. Observe the cursor here. So TBC by sine 150 is equal to 1000 by sine 150. So this sine 50 gets cancelled, and again TABC becomes equal to 1000 only. So TABC is ultimately equal to, sorry, TBC is equal to ultimately 1000 newtons only. Okay, separately write down here, I didn't write here. So next we go for analysis of the second point. So first joint analysis over, we have determined the tension in AB, tension in BC is equal to 1000. Okay, so next we have to go for this joint C analysis. In that condition we need to find out what is the tension in CD. The remaining element will be tension in CD. So for that, so next part, that is joint C. So for joint C, like this we'll be getting the relation. So now represent the angle of angle. So when you take the vertical, so this line and this line both are vertical. So according to the parallel lines theorem, if it is 60, this will be also 60. Okay, and similarly we have to know this value 60 degrees. How this 60 degrees will be obtained means here. So here, observe here, this is given as 120. Okay now, so if it is 120, again according to the parallel lines theorem, this is the parallel line, this is the parallel line, and this line is intersecting these two parallel lines with an angle of 120. So if it is 120, this will be also 120. Observe the cursor. So this is also 120. So when you consider this straight line, total 180. So 180 minus 120 will give you this 60. So that is I have written here 60 degrees. Okay, similarly we need to find out this one 120 degrees ultimately. Why? Because already just now I told you this is 120 means this will be also 120. Okay, similarly next we need to find out this one. Okay, now angle between 1000 load and the CD string. So already it is 60, so total is 180. 180 minus 60 will give you again 120 degrees. Okay, so all the angle of inclinations are same, only 120 degrees. So according to this, try to write the Lamis theorem. So tension in BC, tension in BC by sine of opposite angle, that is 120 degrees, again equal to tension in CD, tension in CD by sine of opposite angle, that is again 120, equal to again 1000 by sine of opposite angle, that is also 120. Okay now, so for finding the CD we need to take the last two terms. So take the two terms TCD. So this sine 120, this sine 120 gets cancelled. So TCD is equal to, ultimately will get 1000 newtons. Okay, we have determined what is tension acting in AB, that is 1732. What is the tension acting in BC, that is equal to 1000 only. Again, what is the tension acting inside CD string, that is again we got here 1000 newtons. Okay, like this we can apply the Lamis theorem for finding the forces or tensions taking place inside a string or in a particular mechanism. Okay now, so according to this diagram, this problem, we need to find out the tension in the strings ABCD. So I hope you understand how to apply the Lamis theorem to this kind of the problems. So Please subscribe to my channel, and if you have any doubt, please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again, thanks for watching my video. Thank you all.